Okay, in this series, this is my seventh video recording for the semester. I would like to emphasize and talk about a problem that I discussed in my last video lecture, and that problem was something called the TCP expiration. This is the TCP session expiring. Okay, so and the TCP session expires usually. Let me show that with the diagram. So this is the client, that's my server. Client issues a request to connect using the method my client equal new socket localhost 8000. Let me change the localhost to an IP address. Let this IP address be 78.25. I'm just using any IP address for that matter. Okay, 78.58.3.22. This could be a valid IP address. You can check it out and you find that this is IP address somewhere in the United States. So my client now, which is a socket on the client side, says a new socket, which means actually says make a connection, or that's what I'm saying here, request connect. That's exactly what this will be. So it's a request to connect to the server, and the server is located at this IP address. So this is the IP address of the server. So let me put it right here so we know this is the IP address of the server. So it will be located here. So the client will issue this request, go to the server, and now the server processes this request at its port 8000, and the server issues an accept statement. The accept statement of the server looks something like this. This is, so let me actually bring it down here. So this is what and let me put it in green, meaning that it is accepted. So the server issues the statement server.accept, and the server.accept will go back to the port of the client. Now, how does the server know the address of the client? The server, from the message, this request to connect message, which is a packet, will be formed, and this will include the return address of the client and the return port of the client. So the server would know where to go and will send this accept statement. So the accept connection goes over the link, and we said there is a propagation delay here, and there is a time to convert the message, to transfer the message from the server to the line, and then to go through the line and to be accepted by the client, assuming all of this time is fine. So the message is accepted by the client. Now here, remember, let me do the following. The reason I want to do that like this, there will be, if you will, here, a delay time. Delay actually by the TCP session, TCP protocol, let me call it, waiting for the accept message from the server. So here there will be some delay time. So when the client issues the state new socket, it will set right here on this port. This is let me put this in red. So the delay actually will be right here. Okay. Now let's make this a little bit thick so it will be visible, and let me make it black. Okay. So this client will be waiting right here. Now, if the client receives the request message when the TCP still has not expired, like the TCP waiting period is long enough, then if I have a statement here at the client says system.out.println connection established, this statement will be printed. So let me put this in green. So this statement will be printed. Only this guy I want. Ah. So the statement connection established will be printed because there is enough TCP session. Now let's look at this scenario, at the second scenario. Let me actually make this a new slide here. And with this slide, let me keep only this guy. So, oh, do I want to do that? Just do it like before. Here, my client will send the new client 78 again to this server, and let me change the IP address. Let me make this 155, and let's make this so that we know it's a different IP address. So this guy, I want to assume that this server is located. What did I do here? TCP session expired. What happens when the TCP session expired? Let's put it this way. Now, as I said, now this is my IP address here. And I will claim that this is too far. The reason I wanted to say it's too far because I want the propagation delay to be too long. So the client now sends the new socket request to connect to the server. Now the server has some delayed message. It will execute the socket client one equal server dot accept, and I assume that the T underscore propagation is very large. Is very large, and also I want to assume that the Ethernet transfer time is also too large. So assume that my Ethernet is very slow and the propagation delay is very large, so the message will be delayed. It will not reach the client. So the client now, when the TCP session, so here, I would say there is a delay. Okay, let me. Too large. The delay is too large. And the port, which is this is my, actually it can be, so the port here will not receive the request message from the server. So this statement system.out.println connection established will not be printed here. Okay. So this will be waiting, and it will not be printed. Why? Because the client fails to receive and it keeps waiting. So the client will keep waiting. Actually, this statement here, if you look at it, new socket here, this will constitute a loop. This is something I did not mention before. So let me write it down here. This statement, my client equal socket 155.58.4.22 at 8. If I want to translate this into a real code, into another code, it will look something like this. Let me show you. It will look like while request not accepted, it will loop check port data. So while request not accepted, you keep check the port data and keep looping. So this is how the system will look. This is a meta code. It's not the valid Java code, but it's a meta code. But that's a translation. While request not accepted, keep checking port data. Now, if you do not accept, if you don't receive the accept statement here from the server, this loop will go into, this was an infinite loop if connection not established. So if the connection is not established, this will be an infinite loop. So that's what the statement is. And then when the TCP session expires and there is no connection, then there will be an error. It will be the system will get an exception and the client will fail. So you will get try this. If you try it at home, just make a client makes my client equal new socket, and then make the server establish a delay before the accept statement, before this client equal server dot accept, establish a delay for let's say 5,000 milliseconds, which is 5 seconds. You'll get an exception here. I'm almost sure you'll get an exception. So that's to simulate the Ethernet transfer time and the propagation delay. You can just create a delay in your program. Now, how do we resolve this issue? How do you make sure? Because at the end of the day, I want the client to connect. If the client fails to connect, I don't want my program to fail. So then that's why you use the try. This is the try and catch. So what you are saying here for this connection, say, try to connect my client to the server. Try to connect. If you connect, then that's fine. Then you jump all the way to this statement. Actually, not to this one, to this one. And you will write connection failed. And if you, oh, actually, no, it's connection established here. Let's say connection, okay, just, okay. Uh, if no connection established, you will not wait. You will wait, actually, you will wait until the TCP session expires, but then which means you wait for 700 milliseconds, assuming that your TCP session is 700 milliseconds. You will wait that much time, but then you will catch the error. And this is try, you catch the error and you say it's an IO exception, and you print the error message. We'll call this E. You print the error message. Actually, you say IO exception E, and then you system, you print, you .out.print, you print the E message. Now, if you don't come here, which means there is no error, if you jump to this part, it means your connection is okay. So in this way, we guarantee that if I have a client server, now I try to connect to the server, but if I fail to connect to the server, maybe I want to connect to another server. See, and that's where the multi or the redundancy comes handy. So here, let me duplicate this slide. Okay, so let me take this out. I don't need this. I will bring this all the way up. And here I will redundancy. See, in case, so if this is, you try to connect, you get the error, and if you get the error here, then you will have another server. So this is server 1. And this is server 2. So you make here request to connect to the server. And you write, so I don't need this statement now. And here I will have system.out print error. And then I will do again my client equal new socket. Actually here I was doing this guy. And here Now I will do my client new socket. Let's say I will do another server. This could be 146.33.2.89, comma, let's say 5004. This is totally different client. So I will make a connection. This is request to connect. And let's say this guy now okay, so this is the accept connection. So this allows me now to be able to, if the server 1 fails, I don't get a connection from server 1, okay? Then I need to connect to server 2, and if server 2 fails, then I will get to server 3, so I can have as many connections as I want. Actually, this issue works, this technique is very useful to connect clients to actually not to connect is useful to provide redundant servers in case one server fails, then the client can connect to another server. But if you don't have the try catch, then the client will keep hanging on the first server. It says, I need to connect to server 1 and I will not connect to anyone else. So either server 1 or none. But then it will be a none and the client will fail to continue execution. Here, I want the client to try server 1, try catch an error. If there is an error, catch it, and then go to the next server, issue. You can use the same port if you want, which is a new socket, because I don't need to create another socket. So my client connected to another server. I provided the IP address and then the port number. If it doesn't work, then I go to another one. Actually, let me uh, say this is, I'll set use case for this technique. Let's say a system has many servers. Servers can be very busy or overloaded. Clients can try to connect to servers, to available servers, or to lightly loaded servers. What do I mean by lightly loaded servers? For example, Let me show a case. This is my client here. And this is server 1. Let's say I have 4 servers. So let me say that client 1 tries to connect to server 1. Assume now server 1 is let me call this down. So it's not functioning. So server 1 is down. So server 1 is down. I should have put this in red. And this guy, okay. So server 1 is down, which means I will not be able to connect. So there is a connection here. And I will put this in dots, meaning that it's not established, and in red to mean that it fails. So no connection. In this case, now client 1, this is client 1. Now client 1 will try to connect to server 2. Now let's say client 2 is up, but it's busy. So client 2 is busy. Now because client 2 is busy, it will not be able to respond in due time. It may respond, but by the time it responds, it will be too late for the message. Okay, let's do it this way. So S1 said we failed. Now S2, so I send my connection to S2, and S2 is too busy. And it fails to connect. So S2 is also busy. And let's say S3 is also busy. So now you try to send message to S3. And okay, is also busy, so there is no connection. Note that client 1, S1 is down, S2 is too busy, S3 is also, let's say, busy. I would say overloaded, doesn't have memory space. It is 2, there is a problem with S3, but it's not down, but the connection fails. Then finally, so all of this connect. And let's say now this guy accept the connection. So we'll make this green, make it solid, and it's accepted. So this becomes very handy in reliability computing systems where we need to make sure that I provide the client with 4 IP addresses, and I will put these connections in try catch, try catch, try catch, try catch, connection 1, try catch, connection 2, this connect 1, connect 2, connect 3, and this is connect 4. So I try 4 times and then hopefully one of these will be accepted. Most likely they will be accepted. So that's why we use this try catch connection, because I don't want my client to fail simply because the server was not available. Uh, all right, and I will stop right here for this lecture, and we'll next time I will talk about, this is I talked about multiple servers. So a client connects to multiple servers. Then I will talk to multiple clients connecting to one server, or multiple clients connecting to multiple servers, and we'll see why they are used, what they are used for. Now, uh, I will make an assignment for you to display a case where the client fails to connect to a server because of time delay, or the server is too busy to respond to the client. Okay, thank you. We'll stop right here.